Hello, this is Team E.A.R.T.H. So we are doing a demonstration here of the mapping of the project room. So I have a Kinect mounted on top of the TriTrack robot, which I'm currently controlling through an Xbox 360 controller over Edge of Wi-Fi. So the Xbox 360 is sending depth data, point cloud, RGB image, as you can see on the left-hand side of the screen. This is sent to the ROS computer, which is then interpreting the data and using with E.A.R.T.H map a 2D map of the room, which it builds as it goes along. You also get a pose estimate and odometry, and you can see the odometry here in the middle of the screen. It gives you a quality rating. This is just visual odometry through the Xbox to Kinect. However, over time we will improve this with more IMU data. So as you can see, as I drive it around, the map is built up here with obstacles. This is a first attempt, and there is more that needs to be done with this map to make it more usable for the project. So as you can see here, as I'm driving it around, there's different obstacles that appear in the map, and you can see on the bottom right hand side the ROS package I've decided to use is done with real-time constraints, and it compresses the data. So even with this RGB image stream, we're only hitting 10 megabits a second, which is perfectly acceptable for the Pi. Here we're using the Pi 4 as well. So all of the processing of that of the Kinect is done there. We're at about 60%, 50% CPU load on the Pi, so we still have some more headroom here. And as you can see now, there's a pose estimate that's appeared on screen. The update rate on that is not the fastest at this moment in time. However, that can be improved. That's just settings tweaking. But yeah. So yeah, as you can see, we're slowly building up a map as I drive it around the. Yeah. And yeah, as you can see, driving it around, makes a map. You can see a reasonable estimate of the project room now. This is not intended to be the map used. We'll make a map every single time, but so as the video draws to a close, thank you very much for watching. This is just a demonstration on the progress towards the capability of autonomous navigation. Thank you. This is just another little video to go into this mapping. So as I was mapping, I was recording this video on my phone. So here's a shot of the TriTrack driving up with the Kinect on top, put on top of a battery. You can see that it's fully on there. There's no additional wires. It's all battery powered. This is the current state of the robot as well, to make that map you saw in the video.